So this video is part of our electrostatics unit, and it's looking at calculating the net force on a charge from multiple other charges. A couple of things we have to remember, and that the first one being that when you look at forces between charges, you have two types of charges, right? So you have to remember that like charges will repel, and that opposite charges will attract. So that's going to be the first thing we have to remember when we put together these sort of questions, is that the type of force, direction of force, is determined by the types of charges that we have interacting. So in this first question, this question example here, we have two positive charges and a negative charge in between them. So let's say we were asked to find the net force on this middle charge from the other two charges. So we have charge A over here, that's 5 microcoulombs, and we have charge B over here, that's 8 microcoulombs. So in both cases we have an interaction between positive and negative. We don't, in this question we don't care about the interaction between A and B, we just care how A and B both affect this middle charge. So if we look at the force from A, it's going to attract the negative charge, so it's going to pull it to the left. The force from B is going to pull it to the right. So now we can set up our equation by looking at the system. Force B is pulling right, force A is pulling left. So if we want to find the net force in this situation, it's the force from B pulling right minus the force from A pulling left. Remember that in electrostatics, our electrostatic force is equal to K Q1 Q2 over R squared. So when we work this out, we're going to have K. The charge from B is 8 times 10 to the negative 6 times the charge that we're looking at. And here, remember that we're putting 4 times 10 to the negative 6. We drop the negative signs when we work through force calculations. So, and that's all going to be over 0.3 squared. From that we subtract K again, and this time we're looking at the 5 microcoulomb charge times 4 microcoulomb charge, that's the two charges we're considering in the question, divided by 0.4 squared. So you can punch that all up into your calculator. To get a number. So we punch that in, we get 9 exponent 9 for K times 8 exponent negative 6 times 4 exponent negative 6 divided by 0.3 squared minus K times 5 exponent negative 6 times 4 exponent negative 6 divided by 0.4 squared, and you end up getting 2.08 newtons if I punch that in right. I think I did. And in this case it would be to the right, because to start off we put to the right as our positive direction and determined the net force on this as right minus left. If the scenario for this question had been different, for example, if this had been a positive charge in the middle, we would still be going negative minus negative. If we had been looking at different scenarios, because based on like charges repel, opposites attract, you could still set up the questions in the same way. The end.